Hello everybody, and welcome to section 1.2. We are looking at the bottom of page 12 here in the workbook, and the topic of this section is the limit of a function. Okay, now up to this point in the course, we've mentioned a lot about rates of change and how a rate of change is a very important concept in calculus, one that's going to keep coming up over and over again. And the limit of a function is a key concept that we need to really tackle this idea of an instantaneous rate of change. Okay, so we're going to spend the section talking about this idea of a limit, starting with this definition. Okay, now, this is kind of a strange definition the same time that the first time that you see it. Okay, so we'll read through this together and then try to make sense out of it with a variety of examples. All right, so let's start reading here. So we say that the limit as x approaches a of f of x equals L, that's the way that those symbols are read in words, if we can make f of x arbitrarily close to L by taking x values sufficiently close to a but not equal to a. Okay, so kind of what this statement is saying is it's a statement about what's happening if we talk about x values that are close to a. Specifically, if x approaches a, this statement is telling us that the y values, f of x, approach the number L. Okay, and the best way to see what this is really saying is to look at a graphical example. All right, so let's look at page 13 together. Example 1 is asking us to take the function whose graph is given to the right and then to fill in the blanks here, to calculate a few limits and function values. Before we do that, there's kind of an issue of graphical notation that I want to address here. So if you look at the graph, you might notice there are some open circles in it. There, and then there. What does it mean when we have an open circle on a graph? Okay, well, an open circle is just a way of saying that a point is missing from the graph. It indicates the absence of a point. All right, and we'll need to keep that in mind as we do this problem. Okay, so let's jump over to the questions that they're asking us, and I'd actually like to start with B here, the calculation of f of 1. Okay, that's asking us to just take the number x equals 1 and substitute it into the function and give the y value. Okay, so x equals 1 is sitting here. What is the y value on our function that goes with that x value? Well, let's see. If we go up, we notice that we've got an open dot. That's an absence. That's the absence of a point, so f of 1 doesn't occur there, but it does occur up here where we do have a point, and the y value there is 3. So if we substitute 1 into our function for x, we get a y value out of 3. Okay, what about D right below it? What would f of 3 be? Okay, same idea. So here's x equals 3. That's what we're substituting in. And where would the output value of our function be? Well, it's not here because there's an open circle, but it is up here because we've got a solid dot, and we can see from the graph that that solid dot occurs at y equals 2. So that must be the value of f of 3. Okay, so we have done 2 of the parts here, and we are ready to talk about one of the limits. Okay, I'd like to look at A, just so that we've got room to work. I'm going to erase the markings that we made so far. Okay, and let's first read in words what they're asking us for in part A here. So it's asking us for the limit as x approaches 1 of f of x. Okay, so this is basically asking us if we take x values that are close to 1, what are the y values of our function close to? You can answer a question like this by first finding the number that you're approaching and then thinking of a number that's reasonably close to 1. Okay, I'm just going to pick a number over here, maybe in the vicinity of 0.5. Okay, let's find the function value at that point. That's right here. And now, remember, we want to approach the number 1. So I'd like to take this point that I've plotted and move towards x equals 1 on my graph. Which way would we need to move to do that? Well, if I want to get closer to 1, that's going to force me to go from this point and move to the right. Okay, so kind of like this, left to right. And the question is, what are we approaching as we do that? I'm going to erase that and do that motion again. So if I start here and move to the right, what are the y values approaching? Okay, we're getting close to this open circle, so it looks like the y values are approaching 2. Okay, and if we had chosen a point on the other side of 1, maybe here, and done the same thing, this time if we approach x equals 1, we'd have to move to the left, so kind of in this direction. What are the y values approaching along that line? Okay, let's trace it out again. Okay, so we're starting here, and we're moving towards x equals 1. What are the y values approaching? Again, it looks like we're approaching this open circle, which has a y value of 2. And therefore, what we would say is that our limit is 2, because that's the y value that we're getting closer to. Okay, maybe one question I could ask you is, do we ever actually get to the number y equals 2? We actually don't exactly reach 2 because of the fact that there's an open circle at that point. But with a limit, it doesn't matter. We're just worried about what we're approaching, and so our answer really is 2. That's the number that we're approaching. Okay, so let's do that same thing with part C. So this is asking us for the limit as x approaches 3 of f of x. Okay, so x equals 3 is here. And we'll do the same thing that we did before. We're going to pick a number that's close to 3. Okay, maybe 2.5. And there's the point on the function. And which way would we have to slide if we want x to approach 3? Well, we'd have to slide to the right, which would take us this way. What do the y values approach when we do that? Well, they're getting closer to this point, which has a y value of -2. Okay, and if we had chosen a number that's a little bit bigger than 3, maybe here, and slide towards 3, this time we'd have to slide to the left, and notice that we're still approaching that same open circle, which is at y equals -2. Okay, and so -2 must be the value of our limit. That's what the y values are approaching as x gets close to 3. Okay. And moving on, we'll look at part E. Our graph's getting a little cluttered, so let's erase some of the stuff that we've written so far. Okay, and E is asking us for the limit as x approaches 4, and one kind of odd feature that we haven't seen before, there's a minus sign after the 4. What does that minus sign mean? Okay, well, the way we would read that in words is the limit as x approaches 4 from the left-hand side. This is what's known as a left-hand limit. And what it means is that we're only going to worry about x values that are less than 4. We're totally going to ignore what happens on the right-hand side of 4. So to calculate this limit, find the number 4 and take a number that's a little less than 4, like 3.5. Okay, here's the corresponding point on the graph. And if we move in the direction of 4, that's going to force us to move to the right. What do the y values approach as we do that? Well, they're getting closer to this point, the solid point, which has a y value of -1. Okay, and so that should be our limit from the left-hand side. Okay, what about the limit as x approaches 4 from the right? Okay, this is what's known as a right-hand limit. Same idea, but just from the other side. So this time we're worried about x values that are a little bit bigger than 4. So maybe over here, like 4.5, there's where our function is. And if we want to slide along the function towards x equals 4, that's going to force us to move to the left. And notice that we're approaching this open circle, which happens to have a y value of 1. So that has to be the value of our limit. Okay, +1. Okay, one more part to go here. And they ask us, does the limit as x goes to 4 of f of x exist? Okay, kind of an unusual question. Well, notice that in this case, there's no plus or minus after the 4. It's just the limit as x goes to 4. And if there's no plus or minus after the 4, what it means is that we want to consider x values on both sides of 4. So here's the key question. Do we get the same result if we approach 4 from the right-hand side and the left-hand side? Well, if you look at our answers to E and F, the answer is no. We looked at the left-hand side and the right-hand side separately, and we got two different numbers. And when that happens, we say that the overall limit, okay, and that's what's going on in G, does not exist. Okay, so this limit does not exist because the limit from the left-hand side of 4 does not equal the limit from the right-hand side. Okay, so there's a very brief preview to the concept of the limit. We're going to do a lot more examples in this section to make sense out of this concept.